So in the last video we looked at why we may wish to use multipass rendering. So now we're going to look at the theory so that we can control our multipass renders and only make changes to our renders in a conscious, artistic manner rather than being led around by the software and finding ourselves with unexpected changes. So the render that you would get straight out of V-Ray we will refer to as the beauty. So in order to calculate that, V-Ray first calculates the different elements that make up the scene and adds them together. So the first of these is what V-Ray calls the lighting element. Now the V-Ray lighting element may confuse those of you who come from another renderer. You may have heard of it called, in something like Arnold, it would be called something like the direct diffuse. So this is the effect of all the lights on all the materials which reflect light in the manner of a brick. In other words, they do reflect light, which is why you can photograph them or see them, but you cannot see your reflection in them. You cannot look at a brick wall and shave or put on your makeup. That's our diffuse light. Now in that layer you will not see anything such as glass or water. You may see fingerprints on a glass, but you won't see the glass itself because that's not diffuse. Now, as all of these things, everything in our scene reflects light, because if it didn't we couldn't see it, it in effect contributes to the lighting. So that bounce light we call global illumination, and that is actually one of the most expensive bits of our render. It's one of the bits that takes a long time to calculate. Next we have our reflection layer. These are the reflections such as mirror or chrome or cars or water surfaces where we can actually see a reflection in it. Maybe that reflection is blurred, as in the case of a plastic toy, or maybe it's very, very clear and sharp, as in the case of chrome. Now there's obviously some spectrum there, because when you get to a certain level of softness of your reflections, it becomes indistinguishable from diffuse. So we would probably advise you to just not calculate it at all and just use the diffuse layer there. Next we have the refractions. Now the refractions are the light that you see within a liquid or glass or transparent material. As photons hit a refractive material, they change speed and direction. Next we have the specular, which is a kind of reflection. It's the pingy highlights you're going to see on a diamond or on a metal object. SSS, which is short for subsurface scattering. You see this if you hold your hand up to a light. You'll see light that shines into your hand, goes through your skin, bounces around off your blood and subcutaneous fat, and then bounces out again, and you get this sort of pink glow. You also get it on plants, where you obviously get this kind of green glow. You get it on wax or marble. So light goes in, bounces around inside and bounces out again. That's subsurface scattering. Self-illumination, the screen you're watching this on is self-illuminating, a phone or a TV. Any practical lights which are within the scene, such as a light bulb which is switched on, would be self-illuminating. Caustics, so the light which is refracted, which then comes out the other side and continues to light the scene, is calculated as caustics. This is very expensive to calculate. If you don't put your settings quite high, it will actually just look quite messy and horrible. So it's one of those things that you're only going to use in a fairly long render. Atmospheric effects, such as smoke or haze in the atmosphere, and the background will be your image plane, if such is visible in your final render. And if you add all those together, you'll get an exact replica of your beauty pass. Now, to make sure that this does work, you have to be working in a linear setup. So the maths, it will only work correctly in a linear workflow, where 1 + 1 = 2 and not something else. And of course, if you don't have any self-illuminating elements, you don't need a self-illumination layer. If you don't have anything refractive in your scene, you don't need a refraction layer. So this equation is a guide only. You often won't have an atmosphere render pass because you won't have any atmospheric effects. So that's the theory. In our next clip we'll be doing that in Nuke.